Okay, so I was just asked a question on how to solve the last two on the section quiz for you physics guys, and it's a lot easier than you guys are making it out to be. Um, I know you're not used to seeing this crazy symbol for density, but that's what it is. I mean, I showed you the row before, even before we left. So this is the density of water times volume times the acceleration due to gravity. So the second squared. And so really all we're doing is this math right here. Now, when you were given 10 centimeters on each side of the cube, so we're going to cube 10 centimeters in meters. This is where the biggest problem arose, is people decided not to convert, right? You have 1,000 kilograms per cubic meter as the density of water. Here you go. This cubed is, God, it's so simple. If you guys had thought about it, 1/1000th of a cubic meter. All right, so 1,000 times 1/1000th is just one. I don't understand why this became such a difficult problem, but hey, let's go ahead and take a look at it. So we have one kilogram, right? Because meters cubed divided by meters cubed cancels out, and then kilogram times 9.8 meters a second squared. Oh, look at that. Kilogram meters a second squared. All right, and does that work for us? Force is mass times acceleration. Son of a gun. There we go. So the answer to this is simply 9.8 newtons, or kilogram meters a second. Right, so that's the first part. Here's the second part. Give me 1 second to bring it up. Come on. There it is. I just needed the density of the steel. The force, the net force is equal to force of gravity. All right. That's kind of annoying. All right. I would say that this is probably more annoying than the previous problem, but I digress. Now we have the buoyant force of the water, right? And that is 9.8 newtons. That's the water. Now we want the force of the steel, so we're going to do the same thing. It's going to be 9,000 kilogram per meters cubed times that same thing, which is 0.1 meter cubed, and then times 9.8. And so we're going to get that force, the force of this object. This is the force of the steel. And we're going to do it the same way. If you already know that this is 1/1000th, and you know that this is 9,000, well, times 9.8. All right, well, geez, what's 9 times 9.8? And that's going to be your total force. Times 9 equals 88.2. Is the force of the steel. That's the steel's weight, its density, pulling down through the water. And the buoyant force is only 9.8. So we want to find the net difference, because the net force is equal to the force of gravity on the steel, and maybe this is where you guys got lost, minus the buoyant force and that's this guy right here. So all we had to do was subtract 9.8 from this, and we would find out 12 is 4, this is 8, and 78.4 newtons, which is just about 78 newtons, right? And that was it. It was not a huge deal, but for you guys not used to doing it over and over again, that's how we get through that. I may give you another couple of these. It seems like we don't know what we're doing. We don't know about conversion, especially, and we definitely didn't know how to do this. And there it is. So we'll try another set. You'll move on and do the stuff for this weekend, but then I'm going to go back and start talking about Archimedes again.